Okay, so let me give you a concept of a unit vector. So I promise this is not actually complicated.
I'm getting it right.
When you see the word unit, what do you think? One?
Something.
Okay, so this is a one vector, roughly. Which means that all you need to do is get a vector that's one long but points in the same direction. Okay? You guys see that? So the question I'm answering is this, like, find a unit vector parallel to, oh, what the heck, let's use our favorite vector from today, 2, 3. Okay? So what I need to do, my thought, is I want to make this a one vector. That's really, I just want to strip the length information off of this thing and leave it as a straight up direction. You guys see that? One way I could accomplish that is I could figure out the angle this makes with the x-axis and I could write a little sentence. That would be annoying. So the thing I'm actually going to do is I'm just going to strip the length information off by making it one long. Okay? So how long is 2, 3 to start with?
Root 13.
Yeah, we found this out before. It's root 13, right? So 2, 3 is square root of 13 long. So how do I answer this question? What's a vector that's one long that parallels 2, 3? 4, 6 is longer, right?
Yeah,
2, 3 is already square root of 13 long, which is like almost 4. Right, so 4, 6 is like 2 square roots of 13 long. So it's going, so how do you adjust backwards? Okay, so here's an idea, right? 1, 3 halves. Okay, see, how did Story get that? He took 2, 3, right, and said, okay, I'm just going to multiply, right, scale and multiply by a half. That should make it how long? 1/2. Half as long as it was before, right? So how long was it before? Square root of 13. So this one is square root of 13 over 2 long. That was a good idea. Maybe it'll lead us down the right path eventually.
What about -2, -3?
-2, -3 is the same length but points in the opposite direction. I want the same direction. Good idea though. Yeah, it's still parallel. So
could you maybe just find the slope of that and like offset it somewhere else? Not from the origin?
yeah, but it'll still be too long.
And length matters when you're just finding something that's parallel?
So I'm just trying to find a unit vector, which means I want to make this thing one long.
So you just divide it by the square root of 13.
Oh, that would work, right? We divided by 2, and we ended up with square root of 13 over 2, right? What if instead of dividing by 2, what if I multiply by 1 over the square root of 13?
What was that?
Remember, scalar multiplication adjusts the length, right? So I took something that was square root of 13 long, I multiplied it by 1 over square root of 13. So now this thing, which is really inconvenient, right? It's 2 over the square root of 13, comma 3 over the square root of 13, right? This looks worse, but is how long? Square root of 13 over 13 is 1 long. So this guy right here is the unit vector I was looking for. You guys see that? This is a good thought sometimes when you just want to know which direction something points in. You guys see that? Because now I could, well, there's some processes I could do with this that we don't know yet, but that you will later. Cool? So this is good because I stripped the length information off. Cool? So out of this, you should add two things. Unit vectors, right, are something that might be handy. They're one long, and you get them by taking the vector you started with and dividing both components by the length. Cool? Questions, thanks?